Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to study a very important topic of class 10 NCERT, that is the last part of first chapter, that is reflection and refraction, and here the topic is the power of a lens. Today we are going to study all aspects of power of lens, what is the physics or story behind power of lens, and how we can just solve, how can we find out the power of lens if two lenses or one lens is given in your hand, and if you are asked to find out the power, then easily you can find it out by listening to today's session. So without wasting time, let us dive in straight to the class. So to the class. So here comes power of a lens. So we have studied two types of lens, and our first one is convex lens and the second one is concave lens. So you have seen this thing, right? And now more precisely I can show that convex lens looks like this, and here a convex lens, concave lens looks like this. That is, for a convex lens you can see the middle portion is bulged, whereas the edge does not bulge, it is thin. So you can see if a ray of light, if this is a principal axis, and if a ray of light is falling on this particular lens, then what happens there? It will converge and it will go like this. So we can say that this convex lens is also known as what? Converging lens. Whereas in the case of a concave lens, if this is the principal axis and if a ray of light is falling on this particular concave lens like this, then what will happen? Instead of converging, it will just diverge the light falling on it, right? So you can see this is a case of a concave lens. That means what? It is diverging all the ray of light which is falling on that particular lens. Which lens? Concave lens. And we call this concave lens as what? Diverging lens. So we have seen two types of lens and how the light will refract after falling on that particular lens. We have seen all those things. And we have seen that either the light will be converging or it will be diverging on falling on this particular lens, specifically convex and concave lens respectively. So the amount of converging and diverging, or the degree of converging and diverging falling on that particular lens, is named as power of a lens. So power of lens is defined as the amount of degree or the amount by which it is converging, the lens is converging or diverging the light falling on this particular lens. That means in the case of a convex lens, it will converge, whereas in the case of a concave lens, you can see that the light falling on it will be diverging. Okay, so we can see converge or diverge. So like this, we can say that this is known as the power. The more the lens diverge or converge, it will have more power. So if the converging and diverging is more, the power of that particular lens will be also greater. So power will also be greater there. So this is the physics or story behind the diverging and converging of a lens as well as the power of a lens. So if I can diverge, if a convex lens is diverging a light, if you have two convex lens in your hand, okay, one is like this and other one is like this. You can see this one is first convex lens and this one is the second convex lens. And what will happen here? You can see if I'm just taking the first convex lens and I'm seeing, I'm just checking how much it is converging. If a light is falling, then it will converge and it will just flow like this or just refract like this. And if I'm just taking the second lens, which is much what? Thicker, or we can say bulger, then what will happen? If a light is falling on this thing parallel to the principal axis, in both cases they are parallel to the principal axis, then here you can see that the light will converge more. It will just converge more than the first one. This is the first case and this one is the second case. So here in these two cases, who is converging the light more? Then you can see the second one is converging the light more. So whose power will be more? Obviously the second lens power will be greater than the first one. So this is about the physics or story behind the power. And the same case, if you're just taking two concave lens also, you can see the same physics. Or if these lenses, just check whether which lens is diverging. In this case, diverging the light more, then that particular lens will have more power. Okay, so now we need to just calculate the power in a mathematical way. This is a physics or story behind the power of lens. Now we are getting into how we can calculate this particular power of a lens. Let us see the mathematical expression for power of lens. So power of lens is defined as the reciprocal of focal length expressed in meters. So if I have a focal length, if I have a lens in my hand and I know the focal length of that particular lens, then how can I calculate the power of a lens? Just simply see, in the previous session I have shown that if, for example, if I'm just taking a convex lens, then I have shown that a light is falling on this particular lens and it just converges and moves like this, right? And you can see that this particular point is known as what? As this particular incident ray. This particular incident ray is parallel to the principal axis, then definitely it will just fall on this, or pass through this particular principal focus, and this distance is known as what? Focal length, right? Yes or no? Yes, you know that thing. And you can see that if I have another convex lens which is much more thicker, and just imagine that the same ray of light which is falling on this particular lens too, then you can see it will just converge it more. And you can see, if I'm calculating the principal focus, this focus is shorter than this focus, right? This focus will be, principal focal length will be, not focus, focal length will be greater than the first one, will be greater than the second one. That means what? As the power increases, here in this case, in the second case, the power is higher. Why? Because it converges the light more than the first case. And here the focal length is shorter. Why? Because it converges it more than the first one. So here, as the power increases, your focal length will decrease. That means they are inversely proportional. So we can say it is inversely, P is inversely proportional to 1 by F. And here, if I want to just change the proportional constant, then I need to multiply it with some constant. I am just taking that constant value as 1. And so we can say it is 1 by F, because using the mathematical clarification, that means experimental way, and if I just calculate, then I am getting exactly the reciprocal of this focal length. So obviously the constant will be having a value 1. So here simply I'm just taking like this, that is, power of a lens is equal to the reciprocal of focal length. And one more thing you need to just keep in your mind, and that focal length should be expressed in which unit? Meters. In meters, then you will have the power of a lens. And one more thing is there, that is, and the unit of this power is known as dioptre, and it is denoted by capital D. You know what is the actual meaning or mathematical expression for this power of lens, and it is the reciprocal of 1 by focal length expressed in meter, and this unit will be in dioptre. Which unit? The power unit will be in dioptre. Okay, now a very important question will be asked for your exams as well as for your other exams also. Define one dioptre. Okay, so let us define one dioptre. So if a question is asked for your exam, that is define one dioptre, how will you do that? For if you are getting such question, first you want to understand that you should take the basic principle, basic equation. And what is that basic equation? Power. You know that power is equal to 1 by focal length, and this focal length should be expressed in meters, right? So, and this will give you dioptre. Just imagine that if this focal length is equal to 1 meter, then your power will be equal to 1 by 1, that is equal to 1 dioptre, because power is expressed in dioptre. So it is 1 dioptre. So when are you getting this particular 1 dioptre? You are getting this 1 dioptre if you have a lens in your hand. If you have a lens in your hand and the focal length of that particular lens is 1 meter. So one diopter is defined as the focal length. The one diopter is defined as the power of the lens with a focal length 1. So that's it. And it can be what? A convex lens or a concave lens. Okay. So here is the definition on the screen. So this is about power of a lens. And here we have seen the individual power. That means if you are given with a lens, either a convex lens or a concave lens, then you can just find it out by using this particular equation, right? But if you are given with a combination of lens, what will happen there? So how can you solve that combination of lens power? So power of a combination of lens is the next topic. So we will see how to deal with that. So how will we calculate the power of a combination of lens? So let us deal. It is simple. Just see that you just take the individual power and you just add the powers, and then you will get the combination power. And for 10th standard, the thing is that this combination means one condition is there, this lens should be in contact. That means this, if I'm just taking two lenses, then definitely the two lenses should be in contact with each other. There should not be any distance between them, because if there is a distance, then the equation will change, and that you will study in your 12th standard. For our convenience in 10th standard, thank God that it's not complicated. Simply you need to just get those individual powers, and you just algebraic sum. Do the algebraic sum. That means you just add it and you will get the combination of power. And this is one case. Another case is that if you are given with two concave lens, and first one is two convex lens, second case is two concave lens, and then sometimes you will be given a combination of a concave as well as a convex lens. So vice versa also, a convex lens as well as a concave lens attached. So here all what you want to do is that you just find out the individual lens power. That is, this is the first lens, and here it is the second lens, first lens, second lens, first lens, second lens, and then you just add it. Just imagine that if you are given with a lens of power D1 and another lens of power D2, power of the combination is given as D1 plus D2. If you are given n lens, then D1 plus Dn, D2 plus D3 plus up to Dn. This is what you need to just do that. Okay, and the next main thing, inference is there, that is a power of a convex lens. First one, a power of convex lens. Is it positive or negative? And here the basic thing is that convex lens is what? A converging lens. Convex lens, you can see that here I am just having a convex lens, and then light ray falling on this convex lens will be converging and moving like so. Obviously the focus, this is principal focus, and focal length is like this, and then this focal length is in the same direction of incident rays, so you will get a positive value. Then the positive reciprocal of a positive value will all is simply it's a positive. So power of a convex lens will be always positive. And the next one is power of a concave lens. What will happen here? For a concave lens, the power will be negative. Why it is so? Why? Because if you have a concave lens in your hand, okay, and if you are just allowing a light to fall on this concave lens, and then just imagine that parallel to the principal axis, then definitely it will just diverge and move like this, right? So virtually you need to extrapolate it backwards, right? So you will get a point here, and this is the principal focus, and this is the focal length, because the length or distance between the optical center and the principal focus is known as what? Focal length. And this focal length direction is opposite to the incident ray, so definitely focal length will be negative. So power means what? Reciprocal of focal length. Reciprocal of a negative term will always be a negative term, so definitely it will be negative. So if you are provided with a negative power, then definitely that lens will be what? It will be a concave lens. And if you are given with a positive power, then that will be a convex lens. Make sure that you just need to know this particular positive and negative value. Why? Because in the case of combination of lens, what happens? If you are given the third case, just imagine the third case and the fourth case, definitely the lens are convex and concave, combo of both convex and concave. So definitely you need to add that thing. You need to add means positive and negative will come, then definitely the subtraction term will also come there. So make sure that you will not go wrong in that particular third and fourth case. And in the first and second case, first case the combination will always be positive, and the second case the combo will be always negative. And here in the third and fourth, it depends upon who is greater, larger, whose power is larger. Accordingly, the effective power sign will come there. I hope that you got the points. And this is about the combination of lens. Make sure that this particular point is very important. You will be asked which type of lens is given in your hands by simply giving you a positive power or a negative power. So that's it, guys. I hope that you got the points, the crisp and clear about the power of lens, and we'll do certain numericals related to the power of lens as well as the other numericals are related to the refraction as well as lens in the next class. So stay tuned and keep supporting as you're supporting till now by your like, share, comment and subscription. So till we meet again in the next class, be safe and just study well. So goodbye and have a nice day.